Okay, so this is number 27 on the 2019 sprint test. So we are given a right triangle 3, 4, 5, and then there are some points inside in a way that D lies on BE. So which means if you connect B and E, so D will be on that line, which is why I just extend this way so we can get that. And the same idea with AF. So if you draw the AF, so E is on that line segment, which is why I have this one. And the last one is DC, and F is on that DC. And then we are given some ratio. So that's what we have right here. And based on that, we want to find the area of the EF. So the first thing I'm going to try using the coordinate approach. So if I can find the coordinates of D and E, D, E, and F, I can use maybe shoelace and then go from there. But the second approach will be area approach. So I hope that will be way better than the first approach. But either way should be useful. So first things first, I want to start with the labeling. Okay, so I'm gonna name the coordinates of E actually as x comma y, and then I'm gonna choose A as 0, 0. Okay, so if this is the case, since we are moving from the origin, x units to the right when you go from A to E, and then E is the midpoint of A and F, so which means the F should have twice as much distance from A in terms of horizontal distance, and the same thing with the Y as well. So that means this is going to be 2x and 2y. Okay, so now we got two things, which is good. And we want to find this point D as well. Like maybe I can connect these point, because this is the x coordinates of this is like x and the y coordinates is y, so which means this is y unit. Okay, and you know that if I want to do the same thing all the way to here, so maybe I should do as well. The reason why I'm doing this, I need to know the coordinates of D in terms of the y's and x, so I can kind of go from there. And then since this is y unit, so that means this is also y unit, because this is just the opposite end of that midpoint. Okay, and then we know this is y, but how this is going to be useful. And we also know that if you look at this triangle, there is a triangle where we see that the ratio, this is 1 to 2x. So if you think about maybe extend this triangle and make a similar triangles. So this triangle and this larger one has a ratio 1 to 3, and that is going to be same as their coordinates ratios as well. Okay, so what I mean by that, if this is like 2y, which is the distance from F to AC, and that means the distance from D to AC has to be 3 times as much. Okay, so which means we actually can say the y coordinates of this point would be just 3y. Okay, so again, if that doesn't make sense, you just extend this and then make a similar triangle. So I hope that will show you that reasoning why that's the case. And then for the x coordinate that we need, we want to find the x coordinates as well. So then this was the x, this was 0. So we want to find the right in the middle, because if you just imagine if this was the case, so this is x unit, right? But this is the halfway between B and E. So which is if you draw this one, this is going to be just half of this much, which is why that will be x over 2. Okay, so we have now x over 2 and all the coordinates in terms of the same variable, but we didn't really get their values. We just need to use those 3, 4, 5 somehow to get their values, right? So maybe we can connect this guy all the way here. And we know that the y value this is 3y, so since this is all y and y, so that means this is also y. So since this is the midpoint right here, this is equal to BD, and then we know this is 2y, so which will tell us this is also 2y. So now we know this is going to be a total of 5y, right? That's 5y, and then 5y is equal to just 3. So then B is just the 3 over 5. I mean, yeah, y equals 3 over 5. Okay, so now we got something, so we can just plug into and then get the values. And to use a similar approach, we can find the other side as well. So like this is the x units from here, this much all the way to here. And if I extend this, right? So this is gonna be like 2x, which means this is also x unit. In total, that's 2 units, 2x units. And if you were to kind of drop this altitude like this, since this is right in the middle, that will divide this x into 2 pieces as well. So x over 2, x over 2. So maybe we should write those. And why this is important, because if I just take the D and then drop this all the way here and then make a triangle right here, then this triangle and the F to this point to C is also similar. And the ratio is 2 over 3. So which means if the distance from this point to C is 3 units, then distance from this point to this point will be just 2 units. So if you use that, so you will get this guy to be 3x. And the whole thing is going to be 5x, right? So, I mean, the whole thing was 4, which is going to be 5x. So the 5x equals 4, and x equals 4 over 5. So again, if you are not convinced with these, make sure you go through and get it before you move on. As soon as we have this, we can just plug into these values and then use the shoelace. I'm going to leave that for you as a challenge to complete the rest, and then you're going to get the answer. But the second approach is quite kind of better than the first one, even though the coordinates approach is usually we like doing it. So let's clean these a bit. Okay, so it's going to be a bit messy. Okay, anyways, I think this is good. So the second approach that I'm going to try, which I didn't finish the first one because I'm going to leave that shoelace part for you, and is using the area approach, which is like sometimes much better than anything else. So if you don't know about what I'm talking, so it's good to review some of the other like videos, maybe that might be helpful. So what I will try in this case, I'm going to name this region as A. So okay, that's A. And now since we have a lot of ratios, it's good to know that is a good hint for us to use the area approach. If I connect B to F, and the reason I'm doing this because we do know the area of this triangle, and then we may find the area of this triangle easily because they share the same vertex. So if this is A, and then since the bases are equal, so that region right here is also A. And now think about the triangle B to this point and F, that's A, B, F, C. They share the point B as vertex, which means the area ratio of these two triangles is the base ratio, which is 1 to 2. If this is A, so that means this is 2A. So we got that. And now think about the triangle BEF. So the area of BEF is 2A, and then BAE, they share the same vertex B, so their base A are equal. So if this is 2A in total, so that means this is also 2A. So now we are almost there. So what we want is just this region, which we don't know that yet, right? But we may find it easily because if I connect the point E to the C, right? So that will give us nice relation as well. So if you look at the E as a common vertex, so I'm going to name this as T, ETF and EFC, they share the vertex E, and then their base ratio is x to 2x, then that's 1 to 2 ratio. The area ratio should be 1 to 2 as well. So which means this is 2A as well. Okay, and then now the last thing we're going to do, AFC, this triangle, has a vertex right here, but that triangle is split into half between this triangle and this triangle. So that means if this is 2A, so that means that is also 2A. So everything add up to the triangle's overall area. So 1, 2, 3, 4, there are 4 2's, which is 8, plus 2 A's, which is 10A. So the 10A is equal to 3 times like 4 over 2, which is 6. So the A has to be 3 over 5. So as you see, the second approach way better than the first approach in this case. but sometimes the coordinates approach like might be the good one. So it is good to know either way. Okay, so this is meant to be 27, which is, you know, challenging question, and especially if it wasn't really obvious when you don't really like draw those segments. When you do so, you can go with like similar triangles help to kind of find their coordinates and then go from there. There's a next approach as well. Maybe you can just use the similar triangles to get the answer as well, but I'm gonna leave that for as extra challenge. Okay, so I'll see you in the next one.